Okay, today, Today we're going to talk about conversion types 3 and 4, and then tomorrow we're going to take our quarter quiz. Monday we'll review all the conversions, and then Tuesday you guys have a quiz over all of them. Tuesday.
Are we going to be able to get rid of the quiz?
Probably. I bet we get enough.
Wait, what about... Wait, never mind.
Wait, can we get rid of our...
I was going to say that for Brittany.
Yeah. Whichever your lowest one is.
What would you keep?
Okay, problem type 3 is really the same process as the last problem type 2, except we're starting with mass and going to moles. But we're using the same conversions. We got to change grams to moles first, though, using the molar mass, and then we'll convert from moles of the first compound to the moles of the second compound.
Are we going to use
No.
avocado?
Avogadro.
Oh, I forgot about the R. Avocado.
Mm-hmm. Okay, the first step in the industrial manufacture of nitric acid is the catalytic oxidation of ammonia. Is that equation balanced?
Definitely not.
Nope, hydrogens aren't. So let's go ahead and start balancing that. 2 here?
Yeah.
2.
Well, 2 here.
Yeah.
And a 3. And then check your oxygens. 2 plus 3 is 5. Ooh, can we get this to be 5? No. So double it. So 4, 4, and 6. And now we have 4 plus 6, so 10. So we'll put a 5 there. Okay, the reaction is run with 824 grams of ammonia. 824 grams. And XX oxygen, which means we don't have to really worry about oxygen in our equation. We'll talk about limiting and excess reagents later on in this chapter, but right now we can just ignore it since we have enough. How many moles of NO? What, Dylan?
We're going to use this one again.
No. Yep, 824 grams of NH3. That's what we start with. Two moles. How do we change grams of one compound to moles of the same compound? We can't switch compounds because we're not going mole to mole. Yep, add up all the nitrogen plus 3 hydrogen. So nitrogen is 14.01 plus 3 times 1.01, so 17.04. Let me make that a little bigger, maybe. That's only when you change compounds and you're going mole to mole. This is grams to mole. Yep, 1 mole. So then, now we can convert moles of NH3, since we're in moles now, to moles. Remember, when you convert from one compound to another, you need to be in moles for both, mole to mole. And these numbers come from your coefficients. So 4 over 4. So really, 4 over 4 is just 1. So if we take 824 divided by 17.04, we'll get the answer. And what is that? Someone have a calculator out? I think it is.
Oh. It didn't look like it didn't look like a normal air.
Questions on that? We'll do another one. But questions on this problem?
I'm sorry, I still scared.
Okay, let's try one more. Okay, this compound, I don't even know how you'd say that one, is effective as a treatment for some cancers. It is synthesized by the reaction shown. Is it balanced? What isn't balanced? That is 2 potassiums, 4 chlorines. There's 2 here and 2 here. Yep. Okay, so it's balanced. How many moles of NH3? So how many moles of NH3 are needed to produce 30 grams of this platinum compound? So we'll start with 30 grams. Instead of writing it all out, I'm just going to put PTCl, and then it's just whatever. There's only one compound that starts with that. No? So we have grams up here we need. Right, we got to add it all together. That's a big one. The molar mass of this PTCl2 NH3 parentheses 2. Yep. So platinum is numbered 78, and it's 195.08, plus chlorine is 35.45 times 2, plus nitrogen is 14.01 times 2, and hydrogen's 1.01 times 6. And what do you get? Well, the mass of platinum.
Just one out.
No, the whole thing. This whole thing right here.
I got it.
Right here. This whole thing. Chlorine's 35.45. Nitrogen is 14.01. Yep. 14.01 is nitrogen, but there's 2 nitrogens.
$299.02. I don't know. I got $299.
Let's see, is it people agree?
I know that's close. I didn't use exact decimal.
I got 300.
311.320. I'm not using exact.
I got 312.
I think 300.06 is what we've got in previous classes already.
Fine with that. Let's go.
Okay, so we'll put that in here, 300.06. I'm just not writing the whole formula up here.
Yeah,
So, yeah, because I don't want to write all those out. Okay, and then we have moles of that platinum compound, PTCl2NH3. Excuse me. And we're converting to moles of NH3, so we need to put moles of NH3 on top.
You have 2 to 1.
A 2 to 1. So 30 divided by 300.06 times 2. 999. Multiplying by 2. The coefficient right here. 60 divided by 300.06. Oh. 0.1999 moles of the PTCl2 Nope, that's not right. That'd be moles of NH3, right?
We're gonna forget.
I think there's some inappropriate parts in that movie.
Not in, is there in the movie?
Yeah,
Have you seen it?
I have it, yeah.
You own it? Please, I'm begging you.
Oh, you're begging?
Monty Python Search for the Holy Grail. It's a movie, it's funny.
Monty Python is like Britain's Saturday Night Live.
Oh, do you guys have questions on that last one? Where any of the numbers came from, or? Okay. Then the last type of problem, that just the same as type 4, where we'd convert grams to moles, moles to mole, but then we're going to convert that moles back into grams. So we're going to use the molar mass of the second compound, convert it back into grams. So you're going to use the molar mass to change grams to moles, use the mole ratio to go from moles of compound A to compound B, to moles of compound B, and then change moles of compound B into grams. So look at this problem. Tin 2 fluoride SnF2 is used in some toothpaste. It's made by the reaction of tin with hydrogen fluoride according to this equation. Is it balanced?
Yes.
Yep, that one looks balanced. How many grams of SnF2 are produced? So how many grams from 30 grams of HF? So I need to start with 30 grams of HF. Myself a little more room. We got to change grams to moles first, so we have grams of HF on bottom,
That's
20.01. Fluorine is 19.998, so you round that to, or 18.998, so you round that to 19 for your answer. Oh. No, you don't. The mass is just 20.01. You don't multiply it by 2. Don't use the coefficient at all.
What's different about this than last one?
We're going to do one more step at the end.
Oh, 90,
Moles of HF on bottom.
60.
Yep.
Repeat that one time.
Right here? Because this is the mass of 1 HF.
So is that always one?
Yeah. Whenever it's grams to moles, then it's always 1. The only time it's not a 1 is when you're going mole to mole. Because it asks for how many grams of SnF2. And then you want to find the mass, and we'll put 1 mole of SnF2 weighs how much? Yep.
You got it?
10 is 118.71. So really, we just added this one step where we got to moles in the last kind of problem. We just got to change moles to grams. So 30 times 156.71, then divide by 20 and divide by 2. And what'd you get? 117 point what?
Blah, blah, blah.
47. Okay. Grams of SnF2. Okay, questions on that whole process? So what gets difficult is when you're given a problem, you don't know which type of problem it is. Like, just start with what you're given, use your units, make sure your units cancel, and convert all the way to whatever units you need. We'll get into a little bit different, but stoichiometry.
I couldn't remember. He said it was. Well, they had to, like, at the beginning, they had to memorize the entire, like, ion chart.
They had ion quizzes, yep.
So that's probably what. I remember him studying it.
Okay, was this equation balanced? Doesn't look like it. Sodium's not. So let's put a 2 here. Balance the sodiums.
So would you like them to use their ion chart for test?
Yeah.
Oh.
So why do they have to memorize it? Just test?
Because they're honest.
And that way they don't have to look it up every single time. They'd get more familiar with it. We could do that in this class
So
too.
I can understand for, like, the sulfates and all that stuff, but, like, the charges.
Doesn't look like oxygen. We have 4 over here and just 3. So let's double it. So make this a 4. So we need to put a 2 here and a 2 here. And now let's look at our oxygens. We have 2 times 2 is 4 plus 2 is 6. And here we have 4 plus 2 is 6. So then we're done. That's all we need. Okay, I want the people on my right to do A. People on my left, you guys have B. Okay, so first group, you start with 50 grams of the Na2O2, right? And then convert that to moles using your molar mass, 77.98 grams of Na2O2 to 1 mole. Right, because whatever you get from the periodic table, that's always the mass of 1 mole of that substance. And then you're going to go from moles of Na2O2, and its coefficient is 2. So you have 2 moles of Na2O2 to 1 mole of O2. Let's get our units canceled here.
Is that the one, the coefficient, or is the bottom one?
Both of these, the 1 and 2, are both coefficients.
So the top one is not the next one?
Right. This one down here is 1 because whenever you convert moles to grams, it's always 1. Right, so then you use the molar mass to convert from moles to grams. And they got 10 point, what was it? 10.2? Dylan, what was it? 10.26. And the other group, you guys should start with 50 also. The mass doesn't change, so this step can stay the same. The coefficient doesn't change, but then we're not converting to O2 anymore. We're converting to water, so our top right here will change. We'll change that to water. So we would have, 2 moles of H2O. And then the mass of water is 18.02. And I don't know what that answer is.
Brittany got like 11 something. 11.55.
Is that right? That's what I got.
Sounds right.
That's what I got.
Okay. Oops. Yep, we do.
Dang it.
Is it like the last night's assignment?
Yeah. Ah. The top. Two. What was it? Two. What page? $293. 1 and 2.
It's not that. It's like just this year. Can't put a Band-Aid on it.
Okay, practice 293. This is D and E, I think. Practice D and E. Yeah. This is the new book numbers. What were the old books numbers? 9 and 11, maybe? Something like that. 309 and.
Does it say you were wrong on your page?